Okay, so we've done the angle-side-angle theorem and the side-angle-side theorem. Now we're going to do the side-side-side theorem. We're going to do it as a theorem instead of a postulate. So this time we've got two triangles. This pair is the same, this pair is the same, and this pair is the same. Okay? So A, B, C, D, D, E, F. Okay, we're starting with this information, and we want to end up being able to say that the triangles are congruent. They would overlap. But we're not sure. I mean, what about the angles? Can we have different angles when we have something like this? We don't know. We got to think about this, reason through it, and prove that they're always congruent. So what we're going to do is get this triangle and put it upside down by this one. So let me go ahead and redraw that. I'm going to get this one, flip it upside down, and put it right here. So we've got A, B, C, and then we had D, E, F. Okay, so since these sides were congruent, they're going to exactly overlap. And then we got this one, and this, and this, and that. Okay? So we're going to try to use our previous theorems to show this is true. Now, notice that if we drew a dashed line down here, we've got this triangle, and we know that it's isosceles, and we know the base angles of an isosceles triangle are congruent, so we know this angle is the same as this one. Okay, there, see our isosceles triangle, two sides are congruent, and then this little angle in here is this one. But on the other side, it's the same thing. Here's an isosceles, because these sides are congruent, and therefore these base angles are the same. Okay? But if we add these two together, then angle B is equal to angle E. Okay? So let's go ahead and write that down. So, one, our given, we know AB congruent to AE, and BC congruent to EF, or this would have been DE, AB, DE, and then BC is congruent to EF, and AC and DF are congruent. G for given. Now, AC and DF overlap. And that's definition of congruent segments, or to say definition of congruent for short, but write down segments when you do a proof. I'm just going to do it like that because of space. All right, and then I'll call this a 1, a 2, a 3, and a 4. So angle 1 congruent to angle 2, because base angles of an isosceles triangle are congruent, and 3 and 4 same thing. So that's scribbling base angles of an isosceles triangle are congruent. But we know 1 plus 3 equals 2 plus 4. Okay. That's just by addition, but that means angle B equals angle E. Okay, kind of the angle addition postulate. Remember that? You were good at picking that out. So those are the same. And now, by the side angle side theorem, side angle side, the two triangles are congruent. We're done. So triangle ABC is congruent to triangle DEF. ABC, DEF. Okay, voila. So notice AB and AE are congruent. We've got that up here. BC and EF are congruent. And the angle made up of those two sides is congruent. So we can use the side angle side theorem. The angle must be made up or in between, must be made up of those sides or in between them. So there, that's the side 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 theorem. So now we can move on to the next section.